Hello, my name is Magdalena Przymorska-Sztuczka and I'm working at the Archaeological Museum in Biskupin. The title of my speech is Archaeological Experiments in the Study of the Textile Economy of the Białbak Culture. In my research work, I focus on acquiring the knowledge of the textile craft of the communities living in the area of present-day Poland in the Late Bronze Age and the Iron Age. Rarely do archaeologists have the opportunity to study both textile tools and the fabrics made with them, discovered at the same archaeological site. Such a situation, however, sometimes takes place in cemeteries of the Białbak culture population. Białbak communities inhabited the northern and eastern parts of the present Polish lands and western Ukraine in the period from the 1st to the 5th century AD. Cemeteries of this cultural unit are characterized by ritualism, and it is in the skeletal graves of representatives of the Białbak culture that both fragments of fabrics and textile tools have been preserved. Receiving funding for research from the National Science Center allowed for comprehensive analysis of fabrics and textile tools from three cemeteries of the Białbak culture population, from Czarnówko-Lubowiec and Wilkowo near Lemberg. These sites are one of the largest, richest, and most thoroughly examined by the excavation method cemeteries of the Białbak culture. They are located very close to each other, only within a radius of 10 kilometers. Thus, they form a complex of neighboring and contemporary necropolis situated in the Lemberg section of the Łeba Proglacial Valley. In addition to textile and tool analysis, experimental work was also included in the project. As part of the research, a number of experiments related to spinning, dyeing and weaving were performed. Today, however, I will focus on presenting only the part devoted to spinning. In the case of textiles, experimental archaeology is of particular importance. Due to the high complexity of the technology, a full understanding and analysis of ancient techniques does not seem possible without references to the craftsmanship actually performed. For this reason, most researchers in this field know how to spin and weave. Thanks to this, the analysis of textile tools focuses on recognizing their functionality and not on the secondary features such as color or admixture for clay in spindle wheels. Archaeological experiments in the field of textiles have a long and still living tradition in Western Europe. A breakthrough in textile research was a series of experiments carried out in 2005-2006 as part of the Tools and Textiles Text and Context project. The research was led by Eva Andersson-Strand and Marie-Louise Noche from the Center for Textile Research at the University of Copenhagen. In my project, through experiments, I tried to answer the following three questions. Is it possible to make a thin thread of high quality using spindle whorls discovered in burials of the Białbak culture population? Do those threads correspond to the parameters of the yarn used to produce the fabrics discovered in burials? Does the use of a number distaff improve spinning, and what is its effect on the obtained thread? Initially, however, I must elaborate on the subject of fabrics of the Białbak culture so that you can understand better the context of my experiments. For a long time, researchers in Poland have been convinced that very high-quality fabrics discovered in burials of the Białbak culture were most likely imports. The similarity of textile technology and the wool quality in Białbak fabrics and fabrics from the 1st to the 3rd century AD from Scandinavia and northern Roman provinces raises legitimate question about their origin. There is no doubt that most fabrics were produced locally, but good fabrics of the highest quality and density, made of fine, perfectly prepared yarn, have been imported. Microscopic analysis of Białbak culture textiles indicate that some of them were made of high-quality wool, often superior to fleece from modern sheep. For example, out of 320 samples of fabrics from Czarnówko, as much as 27% had a thread diameter of 0.3 to 0.4 mm, and 10% were fabrics with a thread thickness of 0.1 to 0.3 mm. Thus, more than one-third of the fabrics from the assemblage were made of yarn with a thickness of less than 0.4 mm. The highest thread diameter recorded in the assemblage from Czarnówko is 0.9. Some fabrics were made of wool, the elementary fibers of which were often in the range of 10 to 25 microns. 1 micron is a 1,000th of a millimeter, and were arranged parallel to each other. For spinning, I used two types of wool: hand-carded fleece from the Wrzosówka ship and combed merino wool. The first yarn was characterized by a high content of camp and core fibers of various thicknesses, which is typical for the fleece of the so-called primitive sheep. The high content of these fibers in the yarn significantly reduces the quality of the obtained thread. They are resistant to twisting, thus protruding from the finished yarn, giving it a specific fuzziness and causing the fabrics to itch. On the other hand, merino wool was characterized by a very high content of undercoat fibers with a thickness of up to 30 microns. In the next research stage, I plan to repeat the experiment using carded wool from Polish mountain sheep, which has an intermediate quality between the two. I used replicas of tools based on finds of whorls, spindles, and the distaff from the cemetery in Czarnówko for the further research. Let me discuss briefly what a distaff is. Generally, in its simplest form, it is a short stick to which the raw material is attached, which is spun into a thread. It can be made entirely of wood, glass, amber, bone, or bronze. There are still discussions as to whether these objects discovered in the graves were only signs of prestige, or whether they could have been used as tools. The answer to this question is provided by research conducted by Annick Hameling from the University of Amsterdam. The results of her works indicate that these objects could be successfully used in spinning. An undoubted advantage of a distaff is that much more raw material can be attached to it than in freehand spinning. During the experimental work, I followed the rules developed by the Center for Textile Research team. I wound the obtained yarn on carton boards 5 cm wide and 24 cm long. The diameter, twist angle, and the length of the thread per hour of spinning were measured. Should anyone be unfamiliar with the production of textiles, it is important for me to explain that the twist angle of the thread is an important parameter because it determines its strength. The tighter the thread is twisted, the more close and durable it is. Therefore, as a rule, warp threads loaded with weights in a vertical loom have a higher twist angle than weft threads. For each thread sample, about 100 measurements were taken. All the other parameters, like the weight of the spindle whorl and the entire spindle, and the weight of the fleece used for spinning, were also measured. For spinning, I used spindle whorls weighing from 5 to 40 grams, with biconical and flattened forms. In the first part of the research, I was spinning without the use of a distaff, from fleece of Wrzosówka sheep and merino sheep, thus fleece containing low-quality fibers and high-quality fleece. I used the two types of wool in order to determine the difference between the obtained thread. I predicted that from high-quality merino wool I would get much thinner and more even threads than in the case of Wrzosówka sheep wool. The results showed that the merino threads are slightly thinner, but the differences of 0.06 mm so unnoticeable to the unaided eye. Small differences in the length of the threads obtained during 1 hour of spinning are also visible, but they are not really significant as well. Nevertheless, the merino threads were more even and definitely less fuzzy, and the twist angle was definitely higher than in the case of threads made of Wrzosówka sheep. Generally, the rule that the heavier the spindle whorl, the larger the diameter of the thread is also upheld. These results are therefore consistent with the overall results of the TTTC experiments. However, the observed differences are not distinct enough for one to clearly state that using a spindle whorl of a certain weight will produce threads with specific parameters. Based on the tests performed, it can only be stated that when using spindle whorls weighing up to 10 grams, the average thicknesses of the threads obtained by me is in the range of 0.2 to 0.4 mm. With the spindle whorls weighing from 15 to 20 grams, the obtained threads have average diameters ranging from 0.4 to 0.6 mm. However, when using spindles loaded with the heaviest spindle whorls, weighing more than 30 grams, the obtained threads have an average thicknesses of 0.6 to 1.5 mm. Yet, the limit values are quite fluid and often overlap. Nevertheless, the diameters of the spun threads, whether those made of Wrzosówka sheep fleece or merino wool, are quite similar to the parameters of the yarn in archaeological fabrics. It also confirms that it was possible to obtain very thin threads using the spindle whorls discovered in Czarnówko. The length of the threads spun per hour are also in line with the results reported by the TTTC team. Depending on the weight of the whorl, 35 to 50 meters of thread can be spun per hour. However, these values for experienced people who had been spinning all their lives must have been much higher. According to Carrington Smith, an experienced spinner achieves from 60 to 110 meters per hour. A comparison of efficiency of amateur spinners and spinners working for economic reasons shows that the efficiency of the former is even worse by up to 40%. In the subsequent part of my work, I focused on capturing the differences in spinning with and without a distaff. Unfortunately, at the time of writing the speech, I managed to finish only spinning with the merino wool. I am still working on spinning with the distaff and fleece from Wrzosówka sheep and Polish mountain sheep. So this part is a partial work report in nature. Nevertheless, differences are visible primarily in the diameter of the spun threads. They are thinner, longer, and more even than using a distaff than their counterparts spun without it. It seems that the threads are also a bit less fluffy. Of course, an experienced spinner will probably get thin threads without the distaff. However, it seems that this tool actually improves the spinning process, and probably in combination with an experienced spinner, it was even more efficient. After partial spinning with the distaff and Wrzosówka sheep fleece, I can also say that spinning with this tool works better with a very well prepared fleece, whose fibers were arranged in parallel by combing. The quality of the raw material used for spinning has a major impact on the quality of the yarn. So the more time was spent preparing the fiber for spinning, for example combing and getting rid of poor quality fibers, the more even the yarn was. The results of the experimental works seem to indicate that it is possible to get thin threads with a diameter of approximately 0.3 mm using light spindle whorls. The parameters of the threads generally correspond to the parameters of the threads in the archaeological fabrics. The use of a distaff in spinning affects the diameter and uniformity of the spun threads. Summing up the research, it can be stated that with the textile tools discovered in the cemetery in Czarnówko, it was possible to spin delicate and thin threads, the parameters of which correspond to the threads used in fabrics also discovered at this site. The use of a distaff in the spinning process slightly simplifies the whole process and makes the spun thread more even and thinner. Thank you very much for your attention.